Hi friends, this is Talluri, Dr. Talluri Upender, Associate Professor in the Department of CSE from CMR College of Engineering and Technology. So in this lecture, I am going to explain dynamic memory allocation. In my previous lectures, I explained about the arrays concept, how to declare an array, how to initialize an array, how to access the elements of an array for both one-dimensional and multi-dimensional arrays, and also I explained how the arrays can be passed to functions as arguments. Okay. Now in this lecture, I am going to explain dynamic memory allocation (DMA), that is also called as DMA. So why we go for dynamic memory allocation means here. So there is a in case of arrays here, when we are reserving the space, when we are declaring one array into, for example, k of 10. So if you declare like this here, what happens means that is a fixed size. Okay, we can't possible to either increase or decrease the size of the array. In that case, what happens here? For example, while taking the elements here, if you want to take the more than 10 elements, okay, the memory will not be sufficient in that case. So again, from the beginning, we cannot modify in middle of the program. So that is one problem. In the same way, for example, if I take only 5 elements out of 10, but I reserve the space for 10 elements, but I am using only 5 element space, the memory may be waste here. Okay, so these are the drawbacks in static allocation. Okay, so to avoid this problem, to overcome this problem, we go for dynamic memory allocation. Dynamic memory allocation. So in this dynamic memory allocation, we can allocate the space in the memory dynamically. Okay, whenever we require the space, for how many elements you want to uh, reserve the space dynamically, you have to decide and reserve the space in the memory, then you have to store the elements in that allocated space. There is no chance to waste of memory. Okay, if you want to expand the size, you can expand dynamically only. Okay, that type of feasibilities are there here, so that's why we are going for dynamic memory allocation. So whenever you want to reserve the space dynamically, there are some predefined functions are there. So one is malloc, malloc. Second one is cloc, and the third one is realloc. The fourth one is free. Free. These are the functions we are going to use to reserve the space dynamically. Whenever you want to implement dynamic memory allocation concept, we use these four functions here. All these four functions are defined in one header file, that is stdlib.h. So whenever you are working with the one of these four header functions here, you must include the header file name, that is stdlib.h. Okay. Now we will learn one by one. First one, malloc function. malloc function. malloc. malloc stands for memory allocation. So how to use this function here? First write the syntax for this one. Syntax. So what is that here? You have to declare that data type followed by a pointer variable you have to take. Pointer variable you have to take. Now that pointer is equal to, here this is you can specify the data type here, data type followed by star, then close the parenthesis. You have to use the malloc function, malloc of n into size of data type. size of data type. Okay, this is the syntax of mlf function. This is the syntax of mlf function. Now here, so here in this case here, data type. So what type of data you are going to store? For what purpose? For storing what type of data you are reserving the space? Okay, based on that you have to specify the corresponding data type here. For example, if you want to store integer type of data, then you have to write the data type name is int int. Okay, so here like that. So a pointer variable you have to declare. Why this pointer variable? Because the mlf function, when the memory is allocated or reserved in the when the space is reserved in the memory, then it returns that the address of that memory. For storing that address, we required a pointer variable. For that I am taking the pointer variable here. Okay, so now come to the point here. Now ptr is equal to, this we will discuss later, mlc of. This function requires only one argument, that is how many number of elements you want to store. You have to specify the n value. N represents number of elements. That elements may be either integers or characters or float, whatever it may be. How many number of elements you want to store, you can specify the n value, and each element occupies how many number of bytes. You have to measure that bytes here with the help of size of operator. Size of the data type. The data type means here these n elements are belongs to what data type. If it is integer means you have to specify size of int. If it is float means you have to specify the size of float, like that. Okay, that for example, if it is float means 4 bytes. 4 multiply with the number of elements. For example, number of elements are 5. 5 4 ja 20. A malak of 20 means what happens here? The malak function. For example, this is the memory. This is the memory. Okay, this is the memory here. In this memory, okay, it reserves how many bytes of space? 5 into 4. 5 4 ja 20. 20 bytes will be allocated. So 20 bytes of block of memory will be allocated for this. Okay, mlc function. So here mlc function does not know what type of data you are going to store in this 20 bytes of space of. Okay, 20 bytes of space, what type of data you are going to store. The malloc function does not know that. That's why in this memory, from wherever the from which address onwards the memory is allocated, it returns that address actually, but it does not know what type of data you are going to store inside the, okay, block of memory. So that's why to this address it adds that keyword is void. It adds the keyword void and then returns to us. That means that it adds that void keyword to this address, starting address of this block, and returns to us. Returns to us. Now we have the responsibility to convert this void type of address into our required format. Our required format means what type of data we are going to store in this block of memory. We know very well. Yes or no? Okay, so that means what type of data, for what purpose we reserve the space for this? That is for storing the integer values. So here we need to convert this void type of address into integer type here. So here the process of converting one type of data, okay, is it clear, into another type of data, that is called typecasting. So how to do the typecasting here? For that purpose, we use that before to this one mlf function, we specify the data type name and followed by pointer. So here I want to convert this, I want to typecast this void type of address into this data type. Data type means what here? What type of data we are going to store? Int. You have to write that int followed by star. Why this star here? Because we are doing the typecasting of an address for not the normal variable. So here I'll write the example also. Example, you have to write that ptr is equal to, where ptr is integer, int star ptr, int star ptr. Ptr is equal to int star of malloc of, I want to take 5 integer values, so that I am taking 5 into size of I want to take the data is integer type. I am specifying that this one. Okay, now here I want to take that, this is the example. This is the example here to understand the concept. Okay, now here, now here as per this example, here malloc function, okay, requires only one parameter, that is 5 into size of int. Now, what is this 5 here? How many number of integer values you want? That you have to specify here. That is 5 integers I want. Each integer occupies how many number of bytes? That I am measuring with the help of size of operator. Size of int. Size of int gives the answer is 4. 4 into 5, 4 5 is 20. So it reserves, malloc function reserves 20 bytes of space in the memory. 20 bytes of block of memory will be allocated or reserved in the memory. After that, in the memory, wherever this 20 bytes of block is allocated, then that starting address will be returns here. Okay, it returns the starting address of that block to us. Okay, while returning, the malloc function adds the keyword to that address, that is void. Why it is returning void here? Adding that data type name is void here, because the malloc function does not know what type of data is going to store in this block of memory. Okay, that's why, so while returning the starting address of this block, it returns that, it adds the keyword void to that address. Okay, now we have the responsibility to convert this void type of address into our required format. Our required format means here we know that what type of data is going to store in this block of memory, we know that. So we need to convert this void type of address into that data type address, data address here, data of data type here. So here now our data is what type of data? Integer type of data. So I want to convert this void type of address into integer. That's why I wrote integer here. Okay. So why this star here? Because I am going to apply that, I am changing the data type of an address, not the normal variable here. So that's why I am using the star symbol. Okay. Now here totally here this statement, the entire this statement, okay, returns that the starting address of that block to us. That address will be assigned to, a pointer. So here this address is belongs to what type of data here? Integer type of data. So that's why we need to assign that address to an integer pointer only. Okay, if you want to take float to the float type of data, means you have to typecast into float type, then the pointer also comes in float type only. If you want to work with character type of data, then you have to typecast into character type, and this pointer also you have to declare under character only. Okay, like that, we have to reserve the space in the memory dynamically for the required number of elements. Okay, once the space is allocated, then you have to use it. That data address is available in the pointer variable. With the help of pointer variable, you can store the data in the allocated block here. Whatever the operation you want to apply, you can do it. Okay, like that we can perform that. Once the task is completed, then before going to exit from the program, we can use the function called free function. What is free function here? Whatever the space is allocated dynamically, we need to, before going to exit from the program, we need to free the space in the memory, then only you have to come out from the program. Okay, so otherwise the data will be stored like that only, that will not be used for any other purpose, and we cannot use that memory, okay, for any other purpose also. Is it clear? So we need to allocate whatever the memory is allocated dynamically. The memory can be freed by using the function called, that is fourth function, free function. How to free the memory here? What is the syntax of this one? What is the syntax for this one here? Means here, very simple here, free of. You have to specify the starting address of that block here. The starting address is available in the pointer. You have to pass that starting address of that block. Then the free function, it frees the whatever the data is there inside this block here, it frees the memory, okay, and the memory will be added to the free space location here, then that will be used for any other purpose. Okay, now before that here, malloc function, if it is unable to reserve the space in the memory, for example in the memory space is not available, so in that case, the malloc function returns what? Means here it returns null. It returns null. This null will be assigned to this PTR. So before going to take the data into the allocated block, we need to check whether this pointer is null or not. If it is null means what? The malloc function is failed to allocate the memory. So if there is no space in the memory means here what we have to do? Can we able to perform any operation without data, without storing the data in the memory? No. So we have to exit from the program. Okay. So like that here. If the malloc function successfully allocated or reserved the space in the memory means it returns that address of that memory to us. That address will be stored in the pointer variable. Okay. Now next to come to the next second function. Second function is CLEC. What is CLEC here? CLEC. CLEC function. Okay. So what is a CLEC? This is also used for allocating the space in the memory only dynamically. What is the syntax of this one here? Same, similar to MLN. There is no change here. One small change is there that I will explain that. That is a data type followed by a pointer variable. Then pointer variable is equal to, you have to do the typecasting here, data type followed by star, because we are doing the typecasting on address here, that's why you have to use specify the star here. Then name of the function is CLEC. Then number of elements, how many you want, you can specify that, that is n. And what is the size of each element here, you can specify the size of the each element, size of data type, size of data type. So please observe that what is the difference between malloc and CLEC here. malloc and CLEC, in malloc function, okay, malloc function, we are passing only one parameter to this function here, that is 5 into size of int means 5 into size of int is 4, 5 4s are 20, that means entire this expression is representing the final result is what, 20 only. That means we are passing only one argument to this malloc function. Okay, but in case of CLEC function, we can pass the two parameters here. One is n and the second one is size of data type. These two are separated by comma, where n represents what? Number of elements. Number of elements. How many you want? You can specify that. The size of data means size of that each element. Size of each element. Size of each element. Okay, how much size it is, you have to specify that. If you take that example, I want to work with 5 integers here. I am taking one pointer, integer type pointer variable, int star ptr, then ptr is equal to data type. We need to perform the typecasting here. I want to work with the integer here, means you have to typecast into the int type here, int star followed by CLEC of number of elements. I want to take only 5 into each element size is 4 bytes. Then semicolon. Now what happens here? If this is the memory, okay, it allocates 20 bytes of black. 5 4s how much here? it multiplies 5 into 4. 5 4 ja 20. 20 bytes block of memory will be allocated. This block can be partitioned into 5 parts here. Okay, 5 partitions here. Each part size is how much here? 4 bytes here. 4 bytes. By default, it stores that the CLX function, it stores the data inside this block is zeros. Okay, by default, the value stored in this block of memory is zeros here. So here the CLX function, so how much space it allocates in the memory means here it multiplies the, okay, these two values 5 4 ja 20. 20 bytes of block will be allocated in the memory. 20 bytes here. Okay, so after that the CLX function also returns the starting address of this block, okay, to us by adding the keyword void. So here it adds that the keyword void to this address. So this XXX represent the starting address of this block here. So to this address it adds the keyword is void. Now we have the responsibility to convert this void type of address into int type, because we want to store integer type of data in this block of memory. So that's why I'm converting this void type of address into integer type. If you want to take only float values means here, then you have to convert void type of address into float. If you want to take characters means you have to convert them into character, like that. Here in which what data type you want to convert, you can convert it into the required data type here. Okay, so finally this address will be converted into the integer type. That is, integer type address will be assigned to a pointer. Pointer is also declared under int only. Okay, now here that address will be assigned to this pointer. Okay, now you have to store that five integers in that allocated space. Then you have to process the data as per the given task. Then you have to use that memory. Finally, after completion of your task, finally what is the final step here? Before going to exit from the program, we need to free the memory. So the memory which is allocated dynamically or not? Yes. Okay, now before going to exit from the program, we need to free the memory with the help of free function, that is free of okay, uh, starting address of the block is ptr. Now the free function goes to the specified address, and whatever the data it is there here, this data will be freed, and that will be added to the free space management, okay, in the memory. Then it comes out here. So that is a purpose of free function here. So once free is completed, next one, realloc. What is the realloc here? Realloc is another function which is used to reallocate the memory. Reallocate the memory means what? Here you may, while doing that, if you want to extend the block of memory dynamically, or if you want to increase the size of the memory, okay, and which is allocated earlier, with the help of malloc or clc function, whatever the memory we reserved dynamically, now I want to increase it, because I want to use some other more number of elements here. In that case, you have to use the function realloc. With the help of realloc function, you have to realloc the memory. Of course, sometimes we may decrease the elements also. In that case, you have to decrease the size of the memory by using the realloc function. How to use the realloc function? What is the syntax of this one? Means here ptr is equal to realloc of ptr comma new size here. New size. What is the new size you want? You can specify that. Okay, so realloc ptr comma new size. Ptr means here what happens here? New size. Here earlier I reserved the space for 5 elements. Now I want to reserve the space for 10 elements here. That is the new size value. Okay, if you want, you can write the example. ptr is equal to realloc ptr comma 10. Means here earlier I reserved the space for, before going to write 10 here, we need to multiply this 10 with 4. 10 4 ja 40. 40 bytes I want to reserve. In previous example, I reserved the space for 5 elements, 5 4 ja, 20 bytes only allocated here. Now with this realloc statement here, it reserves how many bytes of space here? 40 bytes of space here. 40 bytes of space. Now the memory is increased here. Now you can able to take 10 elements into this allocated memory. Okay, if you want you can decrease the size of the memory also. Okay, is it clear? So like that we can use the realloc function. Listen here. So these are the dynamic memory allocation functions here. So here, so what is a dynamic memory allocation means? While execution of the program, okay, dynamically you have to reserve the space in the memory. Okay, so and you have to use it. So if you do like that, what happens means it saves the memory, the space in the memory. That can be done. How to achieve this one means here by using the 4 types of functions: malloc, calloc, realloc, and free functions here. Okay, I hope you understood this concept. Okay, so thank you everyone. So next class I will come with a new topic. Thank you.